Okay, let's continue on looking at some definite integrals and ones that are just a little bit more complex. So, between 625 and 16, let's look at the integral of 4 over the 4th root of x. Okay, so first of all, we need to prepare to integrate by doing a couple of things. First thing, I'm going to get rid of the root, and that will be x to the 1/4. So that's just the nth root of x equals x to the 1 over n. I'm then going to bring this up. So that will be 4x to the minus 1/4. I'm now going to look to integrate by adding 1 onto the power and dividing by the new power. So minus 1/4 and adding on 1, so that's minus 1/4 plus 4/4, which is 3/4. So that's now 4x to the 3/4 divided by my new power, which is 3/4 between 625 and 16. Okay, so let's tidy this up. I'm going to bring the fraction up, flip it over, so that will be 4/3 of 4x to the power 3 over 4 between 625 and 16. Okay, so 4 times 4 is 16, so that's then 16/3 of the 4th root of x all cubed between 625 and 16. Okay, so I'm now ready to make the substitution. So that will be 16/3 of the 4th root of 625 all cubed, minus open up a bracket, 16/3 of the 4th root of 16 all cubed, close the bracket. Okay, so the 4th root of 625 is 5, since 5 times 5 times 5 times 5 is 625. And then 5 cubed is 125. So I've then got 125 multiplied by 16 over 3. Okay, so I've just did a quick calculation of that up there. First of all, 10 125 is 1,250. 625 is 750. Add them together and we'll get 16 lots, so that's 2,000. So that is 2,000 over 3 minus open up. Okay, the 4th root of 16 is 2. 2 cubed is 8. 8 times 16, well, that will give me 128 over 3. That then is equal to 1,872 over 3, which cancels right down to 624. Okay, let's try some more. I'm going to integrate between 20 and 10, z bracket z plus 5. Okay, so let's first of all expand out the bracket. That's part of the preparation. That's z squared plus 5z. Okay, add 1 to the power, divide by the new power. That's going to be z cubed over 3 plus 5z squared over 2. And the limits are 20 and 10, so let's sub them in. Okay, so that's going to be 20 cubed over 3 plus 5 lots of 20 squared over 2, close the bracket, minus open up, 10 cubed over 3 plus 5 lots of 10 squared over 2. Okay, so 20 cubed, that's 20 times 20 times 20, which is 8,000. So 8,000 over 3 plus 20 squared is 400. 400 times 5 is 2,000. 2,000 divided by 2 is 1,000. Minus open up, 10 cubed is 1,000, so that's 1,000 over 3. And 10 squared is 100 times by 5 is 500, and 500 over 2 is 250. Okay, so let's get a common denominator here. 8,000 over 3 plus 3,000 over 3 minus open up 1,000 over 3 plus 750 over 3. So that'll be 11,000 over 3 in this bracket minus open up 1,750 over 3. That will then give me a final answer then of 9,250 over 3. Okay, let's try another. We're going to integrate between 3 and 1. U squared plus 1 over u squared. Okay, so that'll be u squared plus, bring that up, u to the minus 2. And then I'm going to integrate and add 1 onto the power, divide by my new power, u cubed over 3 plus u to the minus 1 over minus 1. That's between 3 and 1. Let's tidy that up. So that's u cubed over 3 minus u to the minus 1 between 3 and 1. Let's continue to tidy it up. That'll be u cubed over 3. Bring that back down using the reciprocal rule, a to the minus n equals 1 over a to the n. And that'll be 1 over u to the 1, which is just 1 over u between 3 and 1. I can now make a substitution. So it's going to be 3 cubed over 3 minus 1 over 3 minus open up 1 cubed over 3 minus 1 over 1. Okay, so 3 cubed is 27, 27 over 3 is 9. So that's 9 minus 1/3 in this bracket, minus open up. And that's just a third take away 1, which is 3/3. Okay, so 27 thirds take away 1/3, minus open up 1/3 take away 3/3 is minus 2/3. So that's 26 thirds minus 2/3 is 26 thirds plus 2/3. Final answer is 28 thirds. Okay, let's try one more of this type. We're going to integrate between 25 and 1, y squared minus the square root of y over y. Okay, so a couple of things I need to do to prepare first. Well, I'm going to split it up. That'll be y squared over y minus, and I'm going to write the square root of y as y to the half over y. Okay, so using the rule of indices, a to the power m divided by a to the power n is a to the power m minus n. I can then continue to tidy up. So y, remember, is just y to the 1. So 2 take away 1, that will just be y to the 1y. Okay, and then remember the power there is 1, so there's a half take away 1, which is y to the minus 1/2. Okay, now I'm in a position to integrate. So add 1 to the power, divide by my new power, that's y squared over 2 minus, well, minus a half plus 1 is minus a half plus 2 halves, which is equal to 1/2. So that's y to the 1/2 divided by 1/2 between 25 and 1. Okay, so that's y squared over 2. I'm going to bring the fraction up, flip it over, so 1 over 2 becomes 2 over 1, that's 2. So that's minus 2 lots of y to the half. I'm then going to reintroduce the root symbol, so that's y squared over 2 minus 2 lots of the square root of y between 25 and 1. Okay, I can now sub things in. So that's 25 squared over 2 minus 2 lots of the square root of 25, close the bracket, minus open up. 1 squared over 2 minus 2 lots of the square root of 1. Okay, so 25 squared is 25 times 25, and that is 625. 625 over 2 minus square root of 25 is 5. 5 times 2 is 10. And that's a half minus 2. Okay, so I'm going to get a common denominator here now. So that's 625 over 2 minus 20 over 2 minus, open up, 1 half minus, I'm going to change 20 halves, so that is 4 halves. 625 over 2, take away 20 over 2 is 605 over 2. Minus 1 half, take away 4 halves is minus 3 halves. So that's 605 over 2 minus 3 over 2, that's 605 over 2 plus 3 over 2, which is 608 over 2. And that can simplify down to 304. Okay, let's try a couple that are slightly more different. Next question is to find the positive value of z, for which the integral between z and 0 of x squared is equal to 9. So let's just see how this question develops. The upper limit is an algebraic term, z, rather than a numerical term, but the lower limit is 0. So let's proceed by adding 1 onto the power, divide by the new power between z and 0, and we're also told that this is equal to 9. Okay, so I'm going to sub in my upper limit of z. So that will be z cubed over 3 minus the lower limit now, 0 cubed over 3, and that's equal to 9. Z cubed over 3, so that's just z cubed over 3, minus 0 cubed over 3 is 0, and that is equal to 9. So z cubed over 3 is equal to 9. Z cubed is 27, and z then is the cube root of 27, so z is equal to 3. Okay, let's try one more. We're going to integrate between z and 1, 1 plus 2x, which is equal to 4. Okay, so integrate a constant and it becomes a constant x, so 1 becomes 1x, and 2x to the 1 becomes 2x squared over 2. That's between z and 1 is equal to 4. So let's just cancel them first. So that's x plus x squared between z and 1 is equal to 4. I'm now going to sub in my upper limit. So that's z plus z squared, close the bracket, minus, open up, sub in 1. 1 plus 1 squared is equal to 4. So that's z plus z squared minus, well, 1 plus 1 squared is 2, so that's minus 2 is equal to 4. That is now a quadratic equation, so how do I solve it? Make it equal to 0 and factorise. So z squared plus z, bring the 4 over, make it minus, so that's minus 2 minus 4 is minus 6, is equal to 0. Two numbers that multiply give minus 6, and add together give 1, is plus 3 and minus 2. So I've got z plus 3 is equal to 0, plus z minus 2 is equal to 0, which gives me two results, z equals minus 3 and z equals 2. But I'm going to select the positive result of z equals 2, since that was what the question looked for in the first place.